Numeric data types include anything you want to do calculations with. This is typically all of your numbers, unless you accidentally make one of your numbers into a char or string using quotation marks. Integer literals, or numbers, are any value that does not have or need a decimal point in it. Remember that assigning a floating point number to an integer variable will work, it just doesn't work well. And anything after the decimal place will be truncated or chopped off the number and dropped. Floating point literals contain every other number that isn't just an integer. Any value with a decimal place in it will be a floating point number. This could be used as a float, double, or long double, but using a double is the default and is what is expected unless the directions state otherwise. Text data types include characters and strings. A character literal is a single letter, number, or symbol that you put inside single quotation marks. The numbers in this case don't work well in calculations, as you'll get the ASCII value instead of the actual number. String literals are a created data type, which means they do require a preprocessor directive that other data types don't require. They take all the characters you type and combine them into one long variable value. Assume the following statement appears in a banking program that calculates data pertaining to loans. Amount equals balance times 0.069. In such a program, two potential problems arise. First, it's not clear to anyone other than the original programmer what 0.069 is. It appears to be an interest rate, but in some situations there are fees associated with loan payments. How can the purpose of this statement be determined without painstakingly checking the rest of the program? The second problem occurs if this number is used in other calculations throughout the program and must be changed periodically. Assuming the number is an interest rate, what if the rate changes from 6.9% to 7.2%? The programmer will have to search through the source code for every occurrence of the number. Both of these problems can be addressed by using named constants. A named constant is like a variable, but its content is read-only and cannot be changed while the program is running. Here's a definition of a named constant. So we have double, the data type. We have the name, interest rate. We still set it equal to 0.069. The difference, the biggest difference, is that we put const in front of the data type to indicate that it is a constant. Please also notice that the name of the variable is written in uppercase characters because that is best practices. The keyword const is a qualifier that tells the compiler to make the variable read only. Its value will remain constant throughout the program's execution. An initialization value must be given when defining a constant with the const qualifier, or an error happens when the program is compiled. A compiler error will also result if there are any statements in the program that try to change the value of a named constant. An advantage of using named constants is that they make programs more self-documenting. The statement amount equals balance times 0.069 can be changed to read amount equals balance times interest rate. A new programmer can read the second statement and know what's happening. It's evident that balance is being multiplied by the interest rate. Another advantage to this approach is that widespread changes can easily be made to the program. Let's say the interest rate appears in a dozen different statements throughout the program. When the rate changes, the initialization value in the definition of the named constant is the only value that needs to be modified. If the rate increases to 7.2%, the definition is changed from const double interest rate equals 0.069 to const double interest rate equals 0.072. The program is then ready to be recompiled. Every statement that uses interest rate will then use the new value. Named constants can also help prevent typographical errors in a program's code. For example, suppose you use the number 3.14159 as the value of pi in a program that performs various geometric calculations. Each time you type the number 3.14159 in the program's code, there's a chance that you'll make a mistake with one or more of the digits. As a result, the program would not produce the correct results. To help prevent a mistake such as this, you can define a named constant for pi, initialized with the correct value, and then use that constant in all of the formulas that require its value. Let's look at how to write a couple of statements using the const qualifier to create named constants. For Euler's number, we would write the const qualifier, followed by the actual data type for this value, a double since there's a decimal point in the number. We give it all caps for its name, and we set it equal to a value. For the number of minutes in a year, we again write the const qualifier first, and then double, since there's a floating point in the number. We write out our variable name in all caps and write out the value. This one is in E notation, so make sure you add that part to the value when you're using it. Finally, we're going to look at the last one. Again, we start with const, but this is an unsigned short instead of a double, since there's no floating point in the value. So, briefly looking at the directions, I see that we have a lot of variables, but not a lot of rows on our table. To fit more variables, you can draw a line through the rows to split them. If you do that, it makes things easier if you keep variables with similar data types in the same row, so you only have to check the data type once for both variables. You can also draw in an additional row at the bottom of the chart if you only have one variable to write in. There are a few things we haven't learned yet, so let's scratch those out: CNing, equations, user directions, input, and processing. We will be writing a program that uses a wide variety of data types to display facts about languages throughout the world. The user would want to use our program to read facts about world languages, which will be your purpose statement. I'm going to write in the values, making sure that data types are the same on each split row, so we only need one check for both variables on that row. We have the longest English word, no repeat, the number of letters. We have the number of countries, number of living languages in the world, number of living languages in the US, which is drastically lower, number of languages in Papua New Guinea, percent of all world language spoken in Europe, percent of all world languages spoken in Asia, the most common letter in English, current world population, and the number of people who speak Mandarin. You need to write code that declares number one as a constant. Remember, const is not a data type, so you will also need to check the appropriate data type in our table. It declares numbers 2 through 10 as variables. It initializes all 10 values and outputs all the values in a meaningful and formatted manner, which means with words so that they all make sense. Make sure you use the best data types in order to receive full credit. Also, please make sure that you document your code with full comments.